Welcome back to the CTO Playbook, the podcast dedicated to helping CTOs excel. I'm your host, Adam Horner. With 30 years in the industry, including over a decade as a CTO, I have coached and mentored more than 100 engineers and tech leaders. This podcast covers crucial topics for CTOs, providing insights, strategies, and practical advice to help you build and refine your own playbook. Today, I'm talking all about engineering strategy. If you've ever struggled with putting together an engineering strategy, or if you've felt the lack of an engineering strategy that aligns with your company's overall objectives, then this episode is going to be for you. Today, I'm going to break down strategy into three key parts. We're going to look at what strategy is, understanding it in terms of its context, the company strategy and product strategy. We're going to talk about building an engineering strategy and how you put that together from three core roadmaps. And I'm going to talk about crafting the narrative that goes with that and the execution plan. By the end of this episode, you'll have a solid playbook with which to create an actionable engineering strategy that supports your role as a CTO. So let's define strategy then. Strategy is a long-term plan of action that's designed to achieve an overall goal. As a CTO, it's essential to understand the context in which our engineering strategy needs to live. There's two key elements to that. One of them is the company strategy, and the other one is the product strategy. Hopefully your organization already has a company strategy. If it doesn't, it's time to assess that with the rest of your executive team. But on the assumption that that exists, and that there is also a product strategy that goes with it, there are several important things that we can take from the company strategy. The company strategy should be looking at key elements like the financial goals, the pain points, the timelines, and the overall objectives. Some companies struggle to focus on the financial metrics and put a lot of, or miss the articulating the customer value that goes in there. So one of the key points that we probably need to focus on is making sure that as a CTO, we understand where the customer value comes from and how the company strategy delivers that in the long term. If we can translate the financial language of the overall strategy into customer value terms and understand the real objectives, it's going to take us quite a long way to understanding what it is that our engineering strategy needs to achieve. But there's one extra layer that goes in there, and that is understanding the product strategy as well. With the company's broader goals, and we have a look at the product strategy, that should then be able to teach us a few extra elements that we need to get out of that in order to be able to build an engineering strategy that's going to take us to the actual targets, to the goals. Key elements would be things like, who is the ideal customer that we're targeting with this solution? What is the value proposition of our solution? What's the pricing model? How are we going to make money from this? Where does the value actually come from in terms of dollars? And then how do we actually reach customers? What's the sales process? What's the sales mechanism? And what's the sales process? If we've got those elements in place, there's maybe a couple of other elements we might want to know something about. How big is it going to be? What scale is it at? For example, if we're looking at a consumer solution, scale is probably going to need to be fairly big and margins are probably going to be fairly small. On the flip side, if we're looking at an enterprise solution that we're trying to build for, then numbers of implementations, numbers of customers, probably quite small, but the value of each one will be quite big. And sometimes the sales cycle will be quite long too. How fast and efficiently does the platform need to work? Is it a high volume, high throughput platform, or is it a one and done kind of platform where speed and efficiency isn't as important? And then lastly, things like threats, competitors, who else is in the marketplace? What are we up against? And what is the main competitor? Don't forget the competitor of the customer simply doing nothing. All of this matters because as we build our engineering strategy, the product strategy extends the company strategy, and the company strategy is what we're actually trying to achieve. And that's what we need to engage with our engineering strategy to actually solve those challenges and those problems. If you've ever worked in an organization where there's been a misalignment between what engineering is doing and what the company is trying to achieve, you'll understand this. For example, I worked in one organization a long time ago now, where the customer side of the business, the sales side of the business was talking about moving fast, being efficient, putting in place quick iterations. And on the engineering side, there was a mismatch. And that was felt by the fact that they were doing things like long release trains. We had vast committees to make decisions. And that speed, which the business side was expecting, just wasn't reflected in the approach that engineering was taken. And that was a sure sign that there was a lack of alignment between the engineering strategy and the product strategy and company strategy. So let's look at moving on then to part 2. Now that we understand what the larger business and product context is, it's time to roll up our sleeves and dive in to the engineering strategy itself. So the engineering strategy is a plan to take the company's goals and translate them into action within the engineering organization. The strategy will have some sort of a time frame. It's normally the same as the strategic planning cycle of the organization. A lot of companies will end up with strategy dealt with quarterly, but some companies will look at it on a 6-month cycle, or in some cases even annually. Whatever your planning cycle is for strategy, that's the time frame that your engineering strategy needs to cope with. It often pays to look 2 or 3 cycles ahead, but it's often not actually very useful to look further ahead than that. Otherwise, we end up risking solving problems or addressing challenges that don't actually exist. Now, we're going to put in place this engineering strategy by creating 3 key roadmaps: one for technology, one for process, and one for people. Now, let's talk about roadmaps for a second. A roadmap, we need to think about it rather than being some sort of fixed plan that's going to have a fixed timeline and a guaranteed delivery. A roadmap is much more like a forecast. If we think about the financial world, we often don't end up making a financial plan. We make a financial forecast, what might happen, what we expect to happen. And a roadmap is exactly the same. It's what we think might happen. It's a forecast, a prediction. It's not a guarantee. And so therefore, when we think about our roadmaps, whether it's a product roadmap, which will hopefully be coming out of the product strategy, whether it's our engineering roadmap, technology roadmap, our process roadmap, or our people roadmap, that's exactly what it should be: a forecast, an estimate of what might happen. So let's think about our technology roadmap then. This is an area where most engineer background CTOs actually don't have too much of a challenge. So rather than going into massive depth on here, I'm going to try and tackle some of the high-level things to think about. And one of the first things to think about is innovation versus stability. If we think about a 2x2 matrix where we've got 2 axes, and on one axis we have the rate of product change, and on the other axis we have the rate of growth. Now, the rate of growth could be in terms of users, it could be in terms of usage, it could be in terms of throughput, but the idea is it's a relative scale of growth. So if we think about that, then we can use that 2x2 to help us understand what kind of technology and what rate of technology we're going to be putting in place. So if we have a high rate of change, so there's lots of product changes, lots of new features being developed, and a low rate of growth, so not much growth in terms of number of users or amount of usage, this is where we're probably in the discovery or innovation phase. This is where we want to be with the engineering, with the technology. We want to be fairly stable, fairly boring, and fairly predictable. We've got plenty of product experimentation going on. And so therefore, if we end up with also having tech experimentation, then we're going to end up with a very confused environment. So when we've got lots of product experimentation, keep the technology simple as we can, as simple as it needs to be in order to achieve the goals, and no more. On the other hand, if we're looking at a low rate of change with a high growth in usage, this is where we're in some sort of hyperscaling environment. And this is where innovation really probably isn't important at this stage because of the fact that we haven't got much changes in the product side of it. This time we want to focus on efficiency, scaling the technology, resolving the bottlenecks that are getting in the way of that growth. And this probably means we need to have a more complex and sophisticated approach to technology as we solve those bottlenecks. Again, focus on the bottlenecks that we actually measure rather than the ones that we estimate or guess might come up in the future. On the top right hand of this 2x2, we'll end up with a high change, high growth. Now, this is the place where we'd love to be. This is the awesome problem to have scenario. We've got lots of change on the product because we're building new features for new customers. We've got a high rate of growth because we're attracting lots of customers very quickly. And this is where we need to find a balance between feature development and paying down tech debt to either resolve bottlenecks, to keep feature development efficient, or to make the support and maintenance of the platform easy. So in this environment, we want to have a bit of a balance between how much complexity we have in terms of technology and how much simplicity we have in terms of running and operating the platform. Now, the last quadrant is low change and low growth. And in this situation, there's one of 2 possibilities. Either the product is basically end of life. I'm going to ignore that one because basically we probably wouldn't be building a strategy for it. So more likely, it's an environment where we've got a cash cow type scenario where we've got a high volume platform that's reached near its maximum size And therefore, it's about efficiency. So we want to be simplifying some of the processes, resolving tech debt that impedes support or gets in the way. We want to consolidate our learnings and processes into automations to reduce the cost of supporting the platform and to make it efficient and easy to run. So that gives us an idea of how much of the technical complexity we expect to have versus how much of the sort of simplicity we need to be aiming for. And when it comes to technical debt, that's also going to be affected by that 2x2 as well, where we can be thinking about how much we want to be paying down tech debt as we go along. So if you think about that quadrant, then think about where your team currently falls in terms of the engineering, and it may be different for different products. And then just think about whether you're balancing innovation versus stability appropriately, and then think about the changes you need to make in order to achieve the correct balance for the current cycle that your strategy is being built for. Be careful of solving scaling issues before you need to. There is very little point in optimizing something that actually shouldn't exist. And one of those, this is one of the points that Elon Musk makes quite nicely when he's talking about SpaceX. If you end up optimizing something that eventually ultimately gets removed or is deprecated or obsolete, you've spent a lot of time doing something that has very little value. So try and avoid that temptation to solve scaling issues that don't actually exist. So technical debt, we mentioned it very briefly there. And we've got to think about technical debt from the point of view of having a general target of, I think, around about 15%. So what is that? What do I mean by 15%? Technical debt is very difficult to quantify in terms of how much there actually is. And so rather than thinking about the technical debt in terms of, how much work there is to do or anything like that, the way I think about technical debt is much like how you think about the interest rate on a financial loan, or whether it's a house loan or a mortgage or any other kind of large loan. And it's the interest rate that is the valuable piece because that tells you how much you need to service on that debt at all times. And I think about it from the point of view of technical debt, of how much time is the team spending on support, bug fixes, analysis of problems, maintenance of the system, and keeping things going. And so if you take that as the amount of time proportional to the total amount of available time that the team has, 15% is one of those values that I've found over time to be roughly right. Different CTOs will give you different numbers, varying anything from 5% for barely touching technical debt up to 40, 50% of the engineering time when you're really paying tech down quite hard. But at the end of the day, you want to have that to be somewhere in that range. And if you think about financial interest rates, yes, they're sort of 5% at the moment. Typically, that's a little low for the tech debt pay down rate because there's also the maintenance and support of the platform as well. So what other key technology topics do we need to think about going into our technology roadmap to think about what changes we might need to make to our current platform for the current period? And remember that our roadmap is a sort of 3-step thing. Every roadmap has a current state and a future state, which implies some transitions in between. And so therefore, what you may also have is a number of intermediate sort of milestone states. And that's all the roadmap is. So it's really is what's the current state and what's the state we want to get to. And that implies the changes that you want to make in between. So other things we might think about going into that change vector in there are things like hosting. How are we hosting? Where are we hosting? What kinds of hosting we're using? What kind of services are we using in there? Which vendors do we need in order to support our chosen solution? And how many of those are critical vendors and how many of them are fungible vendors that we could swap out a solution with a different supplier at any point? How much do we outsource to vendors and how much do we build ourselves? In general, I'd say try and buy rather than build. But there are some environments where you don't want to do that. If you're a deep tech company, for example, you know that you want to break that rule straight away. Redundancy is another important resiliency of the platform. How much engineering do you need to put in place to have high availability and high uptime, for example? Or if you have high throughput, how much do you need for that as well? Security is another important aspect to think about from the point of view of the technology, whether you're using technology products to aid or improve the security, or how much time and effort do you need to put into securing the platform. And then again, is the security strategic? It's a key part of the service that you build, that you deliver. It's an actual value proposition on there. Or is it tactical? We only need to do security because we need to answer security questionnaires from customers. So I've ended up with a couple of different examples in the past where I've been building a platform where security was an absolutely crucial part of it. It was a key selling point of it. And so therefore, the security accreditation and the process for that was really central and was right there in the technology roadmap and really important. And in other times when it's been a sidebar because of the fact that it was just something that needed to be done. It was just table stakes that needed to get put in place, but wasn't an important part of the strategy. So how we go about some of these things brings us nicely onto our process roadmap, which again is going to be a description of the current state and the future state of our processes and how we go about actually running our team and running our engineering. So one of the key things about processes is that for the technology, the current state and the future state is fairly obvious. When it comes to the processes, well, you have some processes or you don't have them. So there's got a couple of ways in which we measure the difference between the current state and the future state. And metrics become a key thing. So that's the way in which we can look at the changes over time in our processes. So some of the processes that we might want to put in place to change metrics might be looking at metrics like the deployment frequency, the lead time, the cycle time. In some examples, we end up with the mean time to recovery in situations where we have high availability or high resiliency, for example. So if we represent our process roadmap then in terms of current state is metrics that look like this and future state is metrics that need to look differently, then we can put in place description of the actual changes we're going to make to achieve those changes in metrics. Another way of thinking about the difference between current state and future state when it comes to processes is standards. By setting standards that we didn't have before, that we want to have in the future, we end up with a definition of the quality of the way that things are done. And those standards will actually drive behavior and cost time. If, for example, let's say we want to put a standard in place that says that we will have a test coverage of 60% for unit tests. By imposing that standard, we cost time of engineers to create new code, and we have a maintenance aspect that goes on top of that as well. So this is one of the ways in which we'll look at processes going in place. So what are the processes that will actually move those metrics from one place to another? Automation is a key thing. In-person versus remote. We're going to have processes that drive behavior, and behavior drives culture. So think about the processes that you want to put in place, not only from the point of view of how do we run our engineering, but how do we want our colleagues to work together and be a team as opposed to cogs in a machine? And so therefore, this is sort of the human aspect of the processes is the culture that we generate by the processes that we put in place. So if you've got a remote team, for example, you're going to want to be able to put in place processes for remote collaboration and communication. How often are we going to meet and get together? And then for other areas, we're going to think about the processes for code reviews, for mob programming or extreme programming. So these are some of the standards and policies that we put in place. Some of the policies will be imposed upon us. We need those for security accreditation or whatever. And so the roadmap, therefore, for processes is probably the least clear one. But it does, again, look like what's the current state, what's the future state, and any interim milestones, which of these new processes we can introduce when. And of course, it's the people that run that. So let's go from there and go on to our third roadmap, which is the people roadmap. What does the people roadmap look like? Well, a people roadmap looks basically like an org chart, which is the state for now, and an org chart for the future. And if we think about a traditional org chart, there's names and a tree of who reports to who, and that's relatively straightforward. But if we want to think about a target org chart, a future org chart, one of the things we're probably going to have to take into account is the growth of the organization, but also the growth of individuals. So we want to have voids or gaps in our future org chart that show roles that don't yet exist. And we sometimes will have a role that's bigger than the person who's currently in the similar role in the current state. When I'm representing radical changes to an organizational chart, I'll often remove individuals' names from it and just put the role titles in. That makes it clear that the transition is not necessarily for the existing people, but might also involve hiring, training, promotions as well. And that brings us on to the idea of how we get our individuals from who they are now, where they are now, the role they're in now, to the role that we'd like them to be in the future. And so therefore, our people roadmap will also include aspects like training, coaching, mentoring, and ongoing learning tools, facilities available to them. And sometimes you might have a formal training program. You might have mentorship and coaching internally. You might have external coaches. And often there'll be a learning budget for engineers to buy books, to source courses for them to do, all self-learning materials which they can use and get access to. So if your team has a clear path for growth, then you need to have resources enough to be able to support that. And that will be part of either the budget or the time allocation or both. Another key aspect with team changes and changing the people structure is when we get to certain key inflection points and setting expectations for those. The one that I'm thinking of most is when we go from one team to two teams. That's when we end up with a bunch of engineers who are originally reporting to the CTO, moving to, let's say, two teams with two team leads and two team leads who report to the CTO. And therefore, we've added in, maybe if we don't even add any engineers in, we've added in two leaders who probably have very little in terms of individual contribution in terms of productivity. And so therefore, we've got quite a large addition of cost with no or very little net addition of productivity, and may even be a dip in productivity as those two new engineering leaders level up and get up to speed and get used to their new roles if they've been promoted from within. So that's one big inflection point that's really important to communicate around. There's another one that comes later on in an organization's growth, and that's when we go from a set of teams to a more complex organizational structure. That could be something that looks like a matrix management organization, where we've got, for example, teams based on products or features. And then we've got the horizontal axis would be skills like the front end, the back end, the DevOps, the product, the design, etc. Often those are sort of sparse organizations when we set them up. So teams have, shared people across multiple teams. So you might be sharing a designer between teams, or you might be sharing a front-end engineer between teams, for example. And that's quite a big transition. And it takes time for people to get used to the way that the matrix works and having leaders on two different axes. So a team leader and a front-end leader, for example. Other organizations might be based on, for example, the squad model, which is or otherwise known as a Spotify model, or something similar. The larger your organization gets, the more variants there are on the way of setting up that organization. But it's moving from that set of teams to a complex organization is a significant transition. And that takes time, it takes planning, and it takes training. And so therefore, it's worth calling that out in your people strategy as to when you get to the point where you believe that's going to be necessary. So if your team is growing, have you thought about the structure that you need in order to support the size of team you have with the right amount of management and leadership in order to make that work? And then the other aspect to think about here is hiring versus promotion. Often when we expand our organization, we end up with gaps for leadership. And there's often a very tempting approach to bring in new hires into the empty roles that we create by expanding our org chart. That's not always going to be the most effective way of retaining talent and of building leadership that has got a good background and experience in the business. If you can promote from within and identify leaders who are, or potential leaders who are already in your organization, it's a really great way to create a growth path for individuals with a promotion possibility into a leadership role where they're looking to do leadership. As several times I've taken organizations from a smaller structure to a larger structure, promoted people from within, and ended up with quite a lot of time spent in coaching on the leadership, but a very smooth transition and a high degree of trust between engineers and leaders where they've been promoted from within teams. Now, we've then got to the point where we've started off with our engineering strategy composed of 3 roadmaps, all of which consist of current state, future state, and some changes or iterative changes to get there in that. And one of the challenges we're going to have with that is that there are going to be some dependencies between them. We're going to end up with some order that needs to happen for those changes to take place. So one of the things you also need to think about is prioritization. So pick any 3 elements from any of those roadmaps, and let's assume that those are the only changes you can make in the next strategic planning cycle. Then think about what dependencies are between those 3 and any other elements of the strategy. And of those 3, which order do you put them in? So stack rank them. And if you take a very tight and strict approach to this prioritization process, the next stage becomes a lot easier to put together. So what is the next stage? The next stage is putting together the engineering strategy into a narrative that we can then use to communicate it to others around the organization. So to communicate the strategy, we're going to turn it into a story. And this is going to be the story that explains the strategy in a relatable, digestible way. It ties all the elements together that we've built so far, and it motivates the team to execute. It should be understandable by somebody who's brand new to the business. So we're going to assume a low level of background knowledge as we put together this story and structure. So it's going to go like this. The first thing we're going to put in place is the background and context. Remember, right at the beginning, we started by looking at the company strategy and the product strategy. The distillation of those two elements and the key parts of it that are relevant for the engineering strategy is essentially the background and context. So from that point of view, the background and context should be fairly straightforward to put together. But it's important to put in place because remember, the target audience here is somebody who's brand new to the business. The next thing we're going to do is to outline the status quo. How is the organization right now? And then we're going to explain why the status quo isn't working or why it needs to change. What's the challenges with it? What's the drawbacks to the current situation that we've got, no matter how we got here? Once we've explained those two sections, the status quo and what's the drawbacks to it, we're then going to highlight the new insight. What is it that we figured out, learned, or understood over the course of the recent time period, and that this should be reflected in those three top priorities? Because it's what are the things that we know we need to change and why do we know it? And then the main part of this strategic narrative is, what is it that we need to change to go forward? What are the changes? What are the changes that we need to implement? In what order? With what dependencies? And what extra resources? That's basically the core of the strategy right there. The last stage then is the outcome. What does success look like? When we've implemented this part of the strategy, what does our future state look like and why is it going to be better? So if you can explain your strategy to a non-technical colleague in about 5 minutes, then you've got a really good narrative. If it takes you a lot longer to explain all of that, then it's time to simplify it and think about it, distilling it down to something that becomes very easy to describe. This is the kind of thing that you're going to be talking about a lot over the next planning cycle, strategic planning cycle. And so you're going to want to make sure it's snappy, easy to understand, quick to digest, and most importantly, easy for you to remember and deliver it. So the execution plan then. The actual delivery of this is making sure that roadmaps are actionable and that everybody understands the steps needed to achieve this strategy. And then we're going to be talking about it a lot because a strategy is, it's fairly worthless if there's no buy-in. So the key thing is the first people who need to buy into this is the rest of our executive colleagues, the rest of the C-suite or senior leadership team. And those are the key people we need to get on board with the strategy first. The second people who are really crucial to this is any engineering leaders we have, or if in the absence of engineering leaders, then the actual engineers who are going to be implementing this strategy and using it as their North Star for the next 3, 6, 9 months, whatever it is. And I've got a really good example of where at the last company I worked at full time, we started out at the beginning of a sort of a 5-year cycle with a really poor state. We had an immense amount of tech debt. We had a previously failed migration attempt to change the technology platform to make it more scalable, more usable. And so in terms of the strategy, the first part, it was fairly straightforward. There was a problem. We needed to fix it. We couldn't scale without it. And so what were we going to do? Well, we're going to re-engineer without disrupting the current platform and make a clean migration. That ended up taking almost 4 years to do. But when we got to the end of those 4 years and were able to turn off the servers, the tech debt that we reduced by doing that was such a weight off our shoulders. But the main thing was that it accelerated the rate of feature delivery that was possible, that previously had just been unthinkable. And I'm happy to say that even to this day, the team is still delivering features at a really good rate of knots. And so having a good, clear strategy that you can communicate to the whole organization is really important. So we started with our company and product strategy. We built our engineering strategy with 3 roadmaps, one for technology, one for process, one for people. We then built our narrative and the execution plan, and then we've communicated it around the business. That is the foundations of a fantastic engineering strategy. So just remember, the engineering strategy should always fit into the bigger picture. The key word here is alignment. If your engineering strategy doesn't align with product strategy and the company strategy, go back and run the playbook again. But by following this 3-part playbook, you'll ensure that your executive team and your engineering team stays aligned with the company's goals and deliver real value through their engineering efforts. If you found today's episode valuable, thank you. Please visit our website to join the CTO Playbook community, where there are more resources and more support for you on your CTO journey. The link will be in the show notes. Thank you very much for listening all the way through to the end. Just before you go, I'd like to ask you for one thing in return for putting together all these episodes of the CTO Playbook podcast for you. Please leave a review. Wherever you're listening, whether that is Apple Podcasts or Spotify or whichever platform you're on, leaving a quick review will help more CTOs find the podcast and enable me to create more great episodes. Thank you for listening, and I'll see you on the next episode of the CTO Playbook.